This is the Math Map Book Club, where ordinary parents encourage one another to develop an extraordinary appreciation of math. We love what we know and struggle over the unfamiliar. Through weekly conversation and exploration among friends, we can begin to enjoy ideas that seem difficult. Join our book club as we discover how math helps us to know God and to make Him known.
Hey, I'm Lee Bortons, and I'm here with my friend Kirsty Gilpin. It's Wednesday, September 6, 2023. Welcome to the Math Map Book Club, where we discuss a concept each week from our soon-to-be-released math curriculum for families with students in classical conversation communities. Kirsty, it's coming up soon. I won't be able to say that soon to be released. It's coming in next spring.
It's getting very close.
Yes.
Which is exciting and a little bit scary all at the same time.
The whole world gets to see me fail or succeed, whichever it is. Well, welcome to everybody, and Kirsty's ready with her PowerPoint, so let's get started.
Well, welcome. We are on week 18, transformations, and I have two images on the screen here on our welcome screen, because if you are working with the Naturals Beta materials at home, you will be seeing the image in the back, Mary and Eve. That was one of the pictures that we were planning to use in the curriculum. And just as things have evolved, that piece of artwork has been changed. And we have changed it to one by Maria Sibylla Marion, who was sort of like a Linnaeus or the Audubon of bugs. And so she created this beautiful piece of artwork here where we see caterpillars and butterflies, which I think a lot of us are familiar with when we're thinking about transformations. So we're really excited at the depth of conversation we can have about this new cover. And so I just wanted to let people know that if they're still pulling things off of CC Connected, it's still that old cover, but when they see the published versions next year, they're going to see this new cover coming up. Oops, there we go. So for our exordium, I thought that this week we would look at the words rather than the images. One of the reasons why is because when we think about transformation, it is such a big part of the Christian life. And so it's right here, sort of in the middle of our 30 weeks, in the middle of what we're doing, that we're going to have such a clear intersection of faith with mathematics, and how math may help us to understand transformation in our own lives. So I'm just going to ask Jill. Jill, would you like to read Paul Tripp's quote? And then Babs, would you read Romans 12:2?
Sure thing. Grace has forgiven you, and one day it will deliver you. But right here and right now, it works to transform you. Paul Tripp.
Okay, in Romans 12:2, and be not conformed to this world, but be ye transformed by the renewing of your mind, that ye may prove what is that good and acceptable and perfect will of God.
So would anybody like to share their thoughts on those words and what they tell us about transformation, and maybe why we chose them for this week?
I'd like to first point out that once again, it's one of the reasons they're well written is because the Trinity's right there. Grace delivers and transforms. And in Romans, it's good, acceptable, and perfect.
Isn't that nice? Isn't that restful? Right? Good, acceptable, and perfect. And it's here with us right now. Like, there's so much encouragement in those words when we think about transformation, and when we think about God and His will for us, and the grace that we receive because of Christ's sacrifice. It's just hope, right? And that's what we know the world needs, and that's what we are hoping, right? We are trusting, right? When Lee said that about failing, from the beginning, I know that this curriculum has been prayed over. And so we've already heard stories of where people have studied math and seen God. And so whatever happens from this point on, we know that God has already brought beauty and goodness from the pursuit of mathematics through the math map. So there is no failure. So Lee, you can know you have already succeeded because God has worked beautiful things through this. And we trust that he is going to continue to work beautiful things in people's lives.
I do trust that. The other thing I noticed is the way you just referred to remind me of this phrase too, also, all right, is that it's the renewing of our mind. Why do we say things like learning and education? Why don't we as Christians say, I'm renewing my mind right now? We should start using that more, I think.
You have
And then I
time,
probably wouldn't have said what I said.
do you have time for one more comment?
Absolutely.
So I noticed conform and transform, they both have that word form in there. And we use that word a lot in CC. There's a form that you can see that, like, let's say the form of a persuasive essay. You can find that in all different areas. But I love the difference that I get in my mind, and con and trans, I could go into that. But when I think of conforming, I think of like checking the boxes to make something look like a form. But transforming is like actually bringing that thing to life, like making the form, like a newborn calf that has the form of a cow. But if there's not spirit in it, if there's not life in it, it's a corpse and it's gross. But if it's got spirit in it, if it's alive and renewed, whatever, then it's a beautiful thing. So anyway, I just think of this curriculum you're building. It's not conforming to the standards. Oh, now we have to do this and we have to do, but it's like creating this whole new understanding of the language of creation, and it's beautiful. Anyway.
Thanks, Jana.
I'm looking at the first quote of the grace is forgiven you and one day it will deliver you. Sometimes that's what we think of when we first become Christians, as we're looking for that deliverance at the end. But it's the right here and right now that's transforming. And transforming happens from that moment of forgiveness through the deliverance, all the way through. There is that transformation. There's never a point at which we should be stagnant. We should be constantly transformed, renewed, so that we can see the good, the acceptable, and the perfect.
That's a great point, Donna, and connecting that with what Lee said, right? That one of the things I appreciate about CC, and when they talk about education, they talk about lifelong learning, right? That where the world has this idea, we do school until you're 18, and then a certain percentage do school until they're 22 or 3, and then a certain percentage, right, do school. But this idea of, as Christians, right, that it's a lifelong transformation. It is lifelong learning. And obviously, first and foremost, through the word of God, right? But we also know through his creation, right, that he's revealing himself through all of these different ways. So we shouldn't stop studying, right? So math is part of that. So it's not just that we're studying math for our children, right? But that we as adults should continue to delight in learning new things about math, or learning new things about literature and so on.
There are even studies that show that when you stop learning, that's when things like dementia and Alzheimer's can take root. So even if I have the Alzheimer's, gene, because both my parents have forms of dementia, that as long as I am continuing learning, I am staving off the inevitable. So that constant learning is very important.
All these proofs, isn't it beautiful when you go, okay, there's this biological proof, there's this scripture, like there's all these things where we see how God really weaves things together, and his creation is the first and foremost example of integration. Good thoughts.
Oh, good. I think we could do this for an hour.
I agree. This is a lesson that has so much to talk about. But we're going to move on to our next slide where we're going to talk about the math map. And what I wanted to point out this week was the idea that maps within the math map, right, and allow us to examine details within the whole. And I was thinking about that as I looked at 2D. And last week we talked about how we've got these repetition of ideas that we keep kind of building on. But as we also look at it, we go, okay, well, we looked at these details with straight lines, and then we looked at intersected lines, which may have built, but it was a separate piece. And it reminds me of the old map books that we had when I was a kid. And I'm sure they existed here, but I always remember the one we had of England. And it was a big grid. It was like the map of England. It's like somebody had this huge, great big map of England and cut it up into rectangles and put it in a book. And I used to love flipping through because you could see all this detail on each page, right? And then, of course, at the end or the beginning, you see the whole thing and you see where each of these rectangles fits in. And I felt like week 18 does that a little bit for us when we're thinking about these maps within a map, that when we see all of these pieces of 2D in week 18, it's an opportunity to go back and talk about, okay, well, what do straight lines look like? What do intersected lines look like? What do curved lines look like? What do polygons look like? What do circles look like? What do, right, all of these different things, when I transform them, right, I'm re-examining all of these ideas. And so it's this opportunity to kind of take all of these little maps that were detail maps and see how they fit right into a whole. So that was my thought today about the language and the order of mathematics, and helping people to see that ideas are not right discrete and separate, but they are truly integrated.
Percy, looking at this, could we have called either 12 or 13 to continue that pattern? Straight lines, intersected lines, curved lines, closed lines?
I would say we could have called them because they're closed shapes but with straight lines, and then closed shapes with curved lines. I'm going to leave it here because we can still talk about it. PowerPoint just changes sides slowly. So that's that pattern, right? Is that the polygons gave us, they are kind of intersected straight lines, but now closed. And then 13 is that idea of a closed curve. And that's where we are. We're on week 18, which I neglected to change on this slide to say lesson 18. I thought I was getting everything, but it is our last week of 2D. So we will go out well and be excited to talk about 3D next week. So again, I don't know where that extra period came from. I was obviously multitasking not well this morning. But we're continually reviewing this dimensional map. And so I wanted to point out, this is one of our charts from lesson 18, transformations. And notice that we stop and we go back and we say, okay, well, when we're talking about transformations, let's talk about our dimensions, right? We're in 2D now, but let's go back and review 0D and 1D. And so in that vein of reviewing, I thought it would be good for us to take a minute and talk about sort of the grammar, dialectic, and rhetoric of transformations. And so for a lot of us, we are still in that grammar stage of transformations, right? If this is our first, especially for our families that are in their first time through the math map, this is likely their grammar year, right? So what are some things, looking at that piece of the chart there, what are some things that we could memorize?
I literally did not know what a transformation was in math. And so the definition there, movement within and between dimensions, that's kind of an important piece of grammar maybe to start with.
That's great.
I think remembering the the points, like what represents 0D, 1D, and 2D, because especially if we're new to the concept of the math map, I feel like that's something that we need to keep reminding ourselves of how we can represent those dimensions. So I think those, and they're short definitions, so I feel like they're familiar enough that we can memorize them quickly.
That's great, Babs.
I agree with Babs that reviewing and constantly making sure that it is solid in our memory about these different dimensions is key. After having worked with the math map for some time and then working with challenge 3 students, I would talk about dimensions, and what kind of equation we were looking at and what dimension might this be. And the math map wasn't available to them. And even though they had done different math curriculums, nobody had dimensions be a focus of their math. I think it's definitely one of the things that sets us apart. It sets this apart, and that is going to bring a lot of enlightenment to the kind of equation we're working with. So it's a simple thing to memorize. They are small, bite-sized, easily understood, especially, a point, a line, a shape, but those things are going to have a huge impact in math down the road. So it might feel like we're not memorizing something big, but I think that we really are.
I know I've spent a lot of time these last 3 months coming to Kirsty's desk, just really clarifying the difference between a line and parts of lines, the segments and the rays. And the better I get at saying, that's right, the answer to this is not like a line, it's half of a line, or it's the segment, I get better at seeing the bounds of things and the things that are infinite. Like it all just keeps tying together to how it all, it's universal. And instead I always thought of all the, like the measurement of a segment being indicated 2 or 3 different ways, depending on what you were doing. Very confusing. And I've gotten to realize it's because I didn't realize how it fit into the big picture of things. And so I'm hoping, I don't expect any of our young children to get that, but I'm really hoping as adults, we keep getting better and better.
So Donna had a good question about why line wasn't listed in 1D. So
Good.
one of the reasons why is because that line is 1D, right? So if I'm just thinking about 1D, that line is all there is, and I can't change that. Once I get into 2D, I can change that line. I can reflect it. I can move it around my plane. But if that's all there is, I can't change the line itself. I can only change things that are on the line, which would be our point segments and rays.
So in 2D, one of your open shapes is the line.
Is the line,
You could have listed that. Okay.
Yes. Okay, so some things, so I think it's a great conversation, right? Especially as we keep going through this, to go back and talk about the language, right? So when we read these things, as Jana just said, right, I need to know what transformation means before I can go any farther. So how do we read things, right? If I look at this, if I was doing this with my family, did we read what it says? Transformation means change. Consider what can be changed, how it can be changed, and how to describe the change, right? So we want to encourage ourselves and our children to be reading, right? That's something that we often skip when we're looking at a math book. We sometimes skip over the words because we think we just have to calculate. And so we're really encouraging everybody, go back and read. And then that first year, maybe that second year, maybe the third year, and throughout, right, we're always picking up new grammar. But those first year or two, it may be just grammar, right? And I just encourage us all to be patient and take the time, right, to get the grammar, and not to think I've got to jump ahead, I've got to become rhetorical, or I've got to become right in 1 year, but to rest in the grammar, which sometimes is memorizing. Sorry, go ahead, Lee.
Oh, this is a place where your children who don't like calculation or the notations can really jump in. As I'm looking at these words that you have blown up, and then looking down at what is to come with the really ugly look at equations at the bottom of the page. That reminds me of my quantum physics class in graduate school, when, like, I just wish I could go back and take it now. Maybe I will, because I'd be able to, it'd be easy instead of hard. But my professor would take these kind of words that were in the instructions, and he would physically act them out behind his desk, running around the room, doing things like that, so that we understood what the words meant. Then the equations weren't so scary. And so that memories I'm sharing with you to remind you that if you have a kid that just doesn't like the math, make them move around and talk about it.
It's such a good reminder. So then let's go ahead and look at some dialectic things, right? So a lot of what we do, and we could use any of the common topics, but comparison is something we're going to do a lot in the math map. So how could we compare the transformations in different dimensions? What can you do in 1D you can't do in 0D? But what can I not do in 1D that I can do in 2D, for example?
Yeah, you can move in 1D by sliding or flipping, stretching or shrinking, but in 0D you can't move at all. And then 2D you add turning. I have to think about that for a minute.
Like rotation.
Yeah.
So if I'm here, I can't rotate, but because I got to do this.
Right.
Rotate.
Not because that puts it into 3D once you rotate. Okay. Is that what you're saying? Like,
Well,
so
it puts it into to 2D, right? If I was on a line, let's say here's my my line that I'm on, and I can't rotate right. If I had a ray, I can't rotate it. I could visualize flipping it right back and forth, but I can't. There's no way I can rotate it around without 2D.
Gotcha.
The flip is the full 180, whereas the rotation could be any degree.
Right.
And that's
So
a
is the
tricky thing, because you can imagine, but you got an origin on a line, and I can say I'm at 3 to the right, or I can say I'm at 3 to the left. And you know that was either a reflection or a rotation, but when you're in 1D, you're not sure how you got there. Right? Because it could also have slid back and forth.
that's what I was wondering too, along those lines. Does that mean that we sort of slid back to where we were and then went the same distance in the opposite direction? Because if we can't rotate off of a line this way, we probably can't rotate off of a line that way either.
Right. There's no rotating, but could I put a mirror, think about as like a 0D mirror on that point, right? So I can have a mirror that reflects, right? So we like to think of that reflection as like, oh, I've rotated, but it's not. This is a strict reflection that goes that way if I'm in 1D, right? So picture that itty bitty tiny little mirror and that ray looking at itself in the mirror, and it would see the opposite thing. So
Forgive me, this is basic, but so what you're talking about is the things you can do within the dimension.
Yes.
Like the transformations is within and between, but we're
Yes.
right now, all this we've been talking about is the
within.
things you can do within the dimension.
Yes. And that's where that last line there, right, talks about the limits. Like that's where we think now if I want to move off that line or move the line itself, I need a second dimension. So now I'm thinking about that bridge to another dimension, right? I need another dimension to look at these things. So that's that idea of movement between, is how I'm limited and then how it would extend. And that's a great question, Dana, because now let's think about what I might want to do in 2D that would require me to go to 3D. Right? What kind of a thing would be, and this is where we're now getting into that sort of rhetorical idea, because we're imagining what might come in the future. And so what do you think you could do that would require you to have the third dimension?
So
Click on, okay.
Crystal asked in the chat, how can we stretch in 1D? Also,
So I'm not going to stretch a point, but I can like imagine a segment. Here we go.
you could stretch a point to be a segment.
No, because the
No?
point, if I have
Because-
nothing times 5,
You still have nothing.
I still have nothing. But let's say here's my line, and right, I have this segment right here, and I wanted to double it. Well, there's different ways we could do it, and so I'm not going to get into the coordinate nature of it, right? But I could certainly take that and double it, and I've stretched it, right? Or I could shrink it. So I can, as long as I'm just doing things on that line, I can do it that way. Now let's go back to Jana's question. And here's our 2 dimensions. Now, if I have this circle, right, I could turn my circle like I'm turning my steering wheel, right? And I'm rotating it. Or I could have it like a gear where it's going around some other point, right? If you've seen those kinds of gears. But what if I wanted to rotate it around my x-axis?
Yeah, that would give it a
That's a
third.
third dimension.
There's my 3D, right? So there's how, depending on what I want to do in 2D, right, I might require, right, I need to move it off the plane. So now I need the third dimension to be able to picture that.
A spiral would be a 3D.
Right. Yeah. So if we're taking things out of the plane, and then, right, and then we can think about what would happen if I had a cube, right? And instead of rotating that cube in space, what would that look like in 4D? I have no idea. Right. But that's
4D imagination, huh?
Ooh, question of the ages.
but there's those rhetorical things that we can do, right? That as I'm looking and comparing, right? So I've now memorized some of these shapes, and I've memorized what some of these transformations mean. And I've looked at comparing these in my different dimensions. Now that rhetorical piece comes in and says, okay, I think I see the pattern, and now I'm going to think ahead, right? What would this look like in 4D? Sometimes we want to jump toward the rhetoric without the first 2 steps, right? And so that's where we need to remind ourselves to sometimes go back and build that memoria and use those common topics. Okay, so just a reminder, coming next spring, the full launch, we will have new and exciting flashcards. We will have the complex domain complete curriculum for challenge A. And for CC connected members, for parents and early adopters, digits, actually naturals will continue to be available. So digits, naturals, and fractions will be available digitally on CC Connected. And the Math Map companion will also be available to all families. So that's a really big deal, that we are making that available to everyone. It is still in its beta state, so it is far from being complete, but there's a lot in there that I think especially those of you who are regulars on our book club are going to enjoy diving into some of the material that's in the companion.
We
All
need
right,
to
so
add naturals to that too. We're gonna keep naturals on for a while. It just won't get updated, but it'll be available. Can I want to give you a Bible verse before you move on. Can I do
Okay.
that? So Zerubbabel was the king who led the 42,000 Jews out of captivity. And Zechariah wrote about him in 4:10. And what he says reminds me of you guys. It says, "For whoever has despised the day of small things shall rejoice and shall see the plumb line in the hand of Zerubbabel." I don't know that you necessarily despise small things, but I see you rejoicing in these small things when we talk about what's a segment and a point and these little things. And because of that, you get to see the plumb line in the hand of the king. Isn't that wonderful?
Lee, that always takes me back to 5th grade. The school I went to in 5th grade had this 5th grade trip every year where we went to this camp, and you could sign up for different little experiential learning things. And so one of the ones that I did was surveying, and so we got to use a plumb bob and transit, and that experience has stuck with me all these years. So
we all need to go buy a plumb line and do some things off the second story. Hey, let's, instead of having car school, we can call it roof school. Everybody get on your roof and use plumb lines and drop things.
that might depend on the roof, how much fun it would be. All right, so I picked a few images from the naturals out for us to talk about, and notice that these the instructions here are simple, right? They're tracing or drawing, but I'm going to ask you to look at these and pull a little bit more information out, right? So we have 4 different transformations listed: the translation, reflection, rotation, and dilation. My first question is, what dimension are we in when we're looking at these images?
Two.
We're in 2D, right? So it's always good, right? We just talked about how important it was to say, what dimension am I in? So this is a good place to start and say, yes, these are all 2D things. So looking at those images along the top section there, can you define or describe what each of those translations does? How would you explain that if you were doing this with your child? How would you describe those words and what was happening?
Could translation be like, you know how a lot of middle school or even teenagers do the electric slide and they're like sliding from one place to the other? Could that be like a representation of like kind of describing how transformation is?
That is an excellent. Now we should all be standing up, right? There we go. So now Lee has given us all away, right? She's thinking about her professor that acted it out. Babs has told us how to act out this one. So, well, we'll put a link to the electric slide in for you.
Well, if you see all the pages of the chart, Kirsty's got dance steps in them.
How
And
about
for reflection, I can only remember being a child and having a mirror on a door and doing the making myself float by having one side reflected.
That's great.
perfect, right? So yeah, so that's a perfect way, right? When we talk about mirrors, that's exactly what we're talking about. How about rotation?
I think I would probably, after the conversation we just had about rotating and reflection, I think a habit that I had as a parent was to not use the word that was written in the book. And in an attempt to talk to my child, translate it in my head and then say something instead of using the word that was written. And when I don't use the word that's written, I'm giving a completely different context. So I need to remember not to say, oh, we just rotated. No, that first one is not a rotation. It is a reflection. The rotation stays in the same plane. So I might use, if I was working with my young child, I would get out a mirror and actually show them that this is a reflection of it. And now let's draw it down here. And I would take a triangle and leave it on the counter and rotate it so it's on the same plane.
That's good. You know, the rotation one, I mean, once again, Kirsty straightened me out. I always think of rotation around itself, and it's really self-centered, my idea of rotation. And she keeps saying to me, no, it's around the origin. So the origin could be yourself if you happen to be standing on the origin, but if you're off the origin and you're rotating, you're actually making a cycle around it rather than spinning around yourself. So that's another thing that you could act out with the kids is where's your origin?
Yeah, there's a difference, isn't there? Like if it's in the middle of me, then I'm just turning this way. But if I was holding my arm out and rotating, right? So that's a different picture there. And I will just interject here that in science, rotation and revolution have separate definitions. In mathematics, they don't. They're not differentiated the way they are in, say, astronomy. So, and then how about dilation?
Well, your pupil, if you shine a light in it, well, maybe the opposite. It's harder to, it's easier to witness the opposite, but it's like the whole thing getting bigger, right? You go in the dark room and your pupil dilates.
And actually, Jana, you're correct, but you're also correct when you say if it gets smaller. So we have a picture here of dilation getting bigger, but it can also get smaller.
Okay, so in
Because
science,
if you-
dilation and constriction are opposites, but here they can be okay, that's helpful to know.
Well, the other thing is, I mean, do we need to consider that? Because what I would say to you is you would dilate based on your scalar. And if it's ×3, it's bigger, but if it's times 1/3, it's smaller.
Right, right, okay.
Can you help me understand how reflection is not on the same plane? Because I'm looking at the second row, and those.
No, it is, Crystal. These are all happening in the same plane. I think
Okay.
Jill was just referring back to that idea of contrasting. If we were looking at just the line and we wanted to say, well, I could have rotated, right? There are some ways that I might use reflection and rotation the same to get the same end image, but when I just had 1D, I can't. There's no reflection. There's no rotation in 1D. I just have reflection. If I was in 2D, then I might say, okay, well, this rotation yields the same after image as this reflection. So, but all of these are staying in the same plane.
Okay, thank you.
Oh, yes, I agree. I'm sorry about that too. When I would not have wanted to pick up the triangle and flip it on the counter and say that because that would come off of that plane. So that's what I would not want to do.
But you have to, because it is the reflection, not the rotation. Like if reflection was a rotation, you could do that, but you have to pick it up to move it over to get the reflection, or you can use a mirror or some other device. But if you're just using one, you can't, like a translation, you can move. A rotation, you can move. The reflection, you have to use a mirror or something else to be able to truly show that.
I think that's what my brain is struggling with right now, because if I look at a mirror, then I'm in a different plane, right? Like a mirror is in a different plane than. So anyway, my mind is kind of blown, but.
Because
Well,
we're
so, but-
3D.
Yeah, I was gonna say, you're thinking 3D there versus just if I'm in 2D, that mirror is essentially just a line. Right? It's not like it's just the line portion.
So if you hold up a piece of paper into the mirror, then to piece of paper, and then the mirror is just a line there, and then the mirror, it would reflect the piece of paper. Because you are 3D, yeah, it's sometimes hard to get the 2D things whenever we live in a 3D world.
So this is a really basic question. So can this transformations only occur in 2D, or can you have 3D objects that like, do you have to have two? Okay, this is fine. Like, we're talking one object that translates or reflects or rotates. We're not talking like two objects. That's one question, that rotate or translate. But can you do that in like, can you have a 3D object that does this? I would think you can.
Absolutely. Yep. We can. So we're focusing in this lesson, we end up really focusing on 2D things because we're still in 2D. But what you're saying is these patterns, right? How we define these words absolutely applies, right? The electric slide, right? There's a translation in 3D, right? And that's one of the hard things is when I try to use a 3D demonstration of a 2D thing. That's where I think that's what Jill was trying to get to is it's hard. I have to be really careful if I'm using a 3D demonstration. I may mislead my student in what that looks like in 2D.
Because we don't have anything that's 2D. We literally don't have anything that's 2D that we can see, right?
Exactly. All right. If it's got depth and we can see it, then it's 3D. So we have to really, right? So even when we're looking at these things, these images, there's some depth to them. It's hard, isn't it? Like, that's hard to go, okay, it's a 3D thing, but we know we can look at it from the outside and go, okay, we're just examining the 2D piece of it. But when we try to demonstrate, sometimes we see other things. But Amy, also to point out, when we do, so if I wanted to, that second image there shows a coordinate plane, right? And an open shape. Now, the way that I would do this calculation wise, if I was looking at that top row and I wanted to do this, I would actually, and for some reason, oh, you know what? You're going to suddenly see a whole bunch of scribbles show up. It's just my computer being slow. So if I wanted to look at those triangles, I would actually look at, I'm going to transform these 3 points and then I'm going to connect them wherever they end up. Right. So that's how I would actually do. I would look at these 3 points. There you go. There's all this scribble showing up. And I would just move those or reflect those or rotate those. And then I would connect them to end up with my whole thing. I wouldn't need to do every single point. Now, when I look at my open shapes, I'm actually going to take this equation and I'm going to change it. And we're not going to go into how, right? But I would actually say, well, this is y equals negative x squared. Right? That's how I can change it. But so there's different ways that we can do it. In this case, I'm by defining it this way, I'm changing every single little point on here. I'm redefining it. But when I look up here, I'm just going to look at these points and then connect them because they're straight. So there's different ways when we're talking about computation and rules that we can do this there. Then my last question, and we're just about out of time, so I'm gonna let you think about how symmetry is related to transformations, right? And I'm going to leave you in anticipation of the release of the entire curriculum, because a lot of us think of symmetry as just being mirror symmetry. And we're going to discover when we get into lesson 18 and the full curriculum, that there's a lot more symmetry available to us when we connect it to transformations. So there's just to whet your appetite and make you super excited for when you get to this lesson in the full curriculum.
I think the greatest thing about all this, Kirsty, is that you have given us the language we need so that when we see something really beautiful, we can say it's because it's balanced around the origin, or it's reflected across the y-axis, or it's been rotated in a way that repeats itself. Like you're giving us the, people always say beauty's in the eye of the beholder, or, I know it's beautiful, I can't tell you why. You're making it so that we actually can renew our minds and capture Christ's thoughts. So thank you for that.
Thank you. So, and again, bad job on my part. I changed everything except the date. So next week will be September 13th. And we will be talking about open shapes in 3D. So all of this struggle we've had this week of saying, okay, there's only 2 dimensions. We're going to just enjoy the next few weeks talking about human space, where we live, where we exist, and we're going to really have fun with this. So until then, have a great week, and I look forward to seeing you next week.
Thanks, team.
Thanks so much.
Thank you.